Today we're going to go over two examples on dividing rational expressions. Our first example is going to be a monomial example that will show us how to divide rational expressions with monomial or single terms. So we're going to start with 5pq over 16p to the third divided by 35p squared q squared over 8q to the fifth. Now the first thing I want to do is I want to change to multiplying by the reciprocal. And this means that we're going to change our division sign to multiplication, and we're going to change our second fraction by flipping it upside down. This becomes 5pq over 16p to the third times 8q to the fifth over 35p squared q squared. Next, we're going to reduce any numeric factors if possible and use the product rule to combine our exponents. By reducing our factors, this makes our numbers easier to work with. So I reduced the 5 and the 35 to 1 and 7, the 8 and the 16 to 1 and 2. I ended up with pq over 2p to the third times 2 to the q to the fifth over 7p squared q squared. Then I added my exponents on the top and added my exponents on the bottom, and I got pq to the sixth over 14p to the fifth q squared. Finally, I want to use quotient rules to subtract my exponents. So this means I'm going to subtract the exponents for the p and for the q variables. This leaves me to q to the fourth over 14p to the fourth. Notice that for p, that variable ended up in the denominator, and the reason why is because that had the larger exponent. So you would do 5 minus 1 and put your answer in the denominator. Our second example involves dividing rational expressions when we have polynomials. Now these are more complex fractions where we might have more than one term. So this time we're going to take a look at 2a to the third minus 12a squared over a squared minus 4a minus 12, all divided by 24a squared minus 8a to the third over a squared minus 8a plus 15. So the first thing in any division problem that you always want to do is, instead of dividing, look to multiply by the reciprocal. So that means we're going to keep the first fraction the same, change the second fraction by flipping it over, and then change our multiplication to division, or division to multiplication. Sorry, change our division to multiplication. After that, we're going to factor everything. And if it doesn't factor, you're going to put it in parentheses. But it's really important that you factor everything and don't try to multiply this big mess out, because you'll just make a bigger mess. So I did that using both GCFs and the box method for my trinomials, means the ones with three terms. And I ended up with 2a squared times a minus 6, and then a minus 6 over a plus 2. Then I have a minus 3 times a minus 5, then 8a squared over 3 minus a. Now in this case, all of my polynomials factored, so I have multiple sets of parentheses. If for some reason your polynomials don't factor, like if you have like x plus 2 or something, just put that in parentheses. Once you have everything factored out, you're going to cross out any matching factors. And if they're opposites, you're going to replace them with -1. What that really means is that you're going to cross out anything from top to bottom that matches. So I'm going to use the pen to kind of show you what I did. I crossed out the a minus 6 and the a minus 6. I crossed out the a squared and the a squared. I crossed out the a minus 3 and the 3 minus a. And I replaced this with -1. I also crossed out the 2 and the 8. And I replaced the 8 with a 4. Okay? Once you've done that, you're going to multiply whatever is left and write your final answer. So on the top, all I have left is -1 and a minus 5. And I multiply that out to become -a plus 5. On the bottom, all I have left is the 4 and then the a plus 2 in parentheses. And I multiply that out to get 4a plus 8.